We pressurize hydrogen in the first section. In the middle of the gun, there's a barrel. That's where the projectile is held. The pressures that are generated from these guns can actually level the building. And that pressure is suddenly released where the projectile is, where the barrel in the middle of the gun is. And then from that point on, there's a simulated vacuum, which simulates space. And then it is impacted where the target is.
It's all about the timing. You're dealing with about 500 microseconds. Where's the time of the event?
So unlike a traditional firearm, a lot goes into preparing these guns for a shot. Setup takes anywhere from an hour to a full day. Gunpowder is prepared and loaded by hand.
We're able to remotely operate the guns via the bunker. On the count of 3, 3, 2, 1. It's equal to 25 times faster than a .44 mag. The velocities are also like flying from New York to San Francisco in 5 minutes.
One of the interesting things that we learn is that a massive piece of metal does not offer the same level of protection of really thin pieces of metal, but stack all together. What we're doing is we have very light layers of material, and those layers, they function to progressively break the particles until the very last layer that just receives all the energy from the hit, and it stops right there.
If it wasn't for this study, we would be sending up rockets and satellites and pieces of the space station not knowing whether they were going to protect the astronauts or the equipment we send up.
It's a really neat thing to see when you test something and have it correlate very well back to your simulations. I am super excited to be working this mission to bring back samples from Mars. It is something that has never been done before.
And we are learning so much from this, especially because it's Mars. It's a planet that we had fascinations for a very, very long time. So it is humbling and a lot of work, right? Being here, testing things, it's amazing.